I would like to briefly introduce myself and our company and our founder as well. I am Subhashini Singh and I'm a forensic solutions consultant at forensicsguru.com. Here are a few details about our founder, Mr. Samir Dutt, who is regarded as the pioneer of Indian and South Asian digital forensic industries. Since 1999, he has been the founder and CEO of Forensics Guru. He founded Forensics Guru at a time when very few people were knowledgeable about forensics. He has over 30 years of experience in the United States, the United Kingdom, and in India. He is also the president of Digital Investigators Association, as well as an alumni of NIT Rourkela, IIT Kanpur, and IIFT Delhi. In addition, he is a fellow of Indian Police Foundation. He is a great public speaker who has spoken at National Police Academy, CBI Academy, and ICFS Delhi, and in many other events in India and in abroad as well. He is also a TEDx speaker and the author of the best-selling book on learning network forensics. A quick company overview. So our company was founded in 1999. So as a result, we are the oldest company in the computer forensic and digital investigations market. We are basically headquartered in New Delhi, and our digital forensic laboratory is in Faridabad. So this digital forensic laboratory is fully equipped with most up-to-date tools and technologies from across the world. We are also, and we have other branches as well in Jaipur and Hyderabad. We are also ISO 9001 and ISO 27001 certified company. So we have been working in this field for years and have achieved a number of milestones. In fact, India's Honorable Prime Minister Shri Narendra Modi is extremely interested in digital forensics, and several dignitaries also come to see our tools and technologies. You can also see me in one of the pictures with the Defense Minister of India, Shri Rajnath Singh, complimenting our products at one of the events. So we have earned several accolades, testimonials, and awards, among other things. We are a NESCOM immersed company, and we are the only NESCOM immersed 50 company in this particular field of computer forensics and digital investigations. We have many satisfied customers all around the world who have spoken positively about us. So here are a few appreciation letters from these customers to show you. So one of the appreciation letter we got or we received from UNDP after completing a training session from them. Next letter of appreciation we received from the Indian Army. So the Indian Army was investigating a particular difficult issue involving targeted Chinese malware. So we helped the Indian Army in their investigation of the malware. And one more appreciation letter we received from Delhi Police. So we actually helped Delhi Police in solving a sensitive kidnapping case and also recovering a huge amount, which is of 1 crore 38 lakhs from the offender. Alright, so we have an extensive list of customers. So we have clients in all different categories. We have clients in national security areas. In fact, all the 2 letters, 3 letters, and 4 letters agencies are our customers. In the defense zone, the Army, Navy, and the Air Force, they all are our customers. all the state police forces, and most of the union territory police forces, they are our true customers. So we also work with the private sector. If I talk about the big four companies, so all big four companies are our clients, KPMG, Deloitte, PwC, Ernst & Young, and other companies as well, like Vodafone, IBM, they all are our clients. So in government sector as well, different organizations such as MHA, CERT India, SEBI, etc., they all are our true customers. Not only this, across the country, we have established a number of digital forensic labs. Recently, we established a lot of CCPWC laboratories. These are well-equipped digital forensic laboratories. So here are few pictures from these laboratories to show you. So we established these laboratories in Jaipur, Chandigarh, Sikkim, Gangtok, Shillong, Daman, and in Assam. All right. So today's webinar is basically focused on two things. So very first, that learning about child sexual offenses, and also a little bit learning about POCSO Act, which is Protection of Children from Sexual Offences Act. And second, which we will talk about, is understand the way to identify digital evidence in cases related to POCSO or POCSO investigations. So first, let's talk about POCSO Act, a little bit talk about POCSO Act. So basically, this act is made for children's safety. POCSO Act 2012 and the related rules to this act were developed with the goal of safeguarding children from variety of sexual offenses, and also creating a child-friendly judicial system for dealing with such offenses. So here, the law related to these offenses punishes not only the offender of the sexual assault, but also those who fail to report the offense with either jail or with fine or with both. So, when it comes to investigate these kind of offenses involving child sexual abuse, the investigation is conducted in multiple directions. Because children's sexual abuse is a crime that can be committed in multiple ways, such as one of the ways is creating child pornography, means creating sexual videos or child sexual abuse material like CSAM for the purpose of sexual satisfaction and for earning money as well. And you must have heard that nowadays children are kidnapped for a business in which they are forced to participate in some online sexual activity that any customer from a foreign nation demands. And any kind of the next situation could be that any kind of online sexual harassment of a child, as well as sending or publishing any sexual exploitative content about any children. One more thing, that nowadays dark web is being used for businesses related to the child sexual abuse material. So if I will particularly talk about the dark web, so this portal distributes massive amount of child sex abuse content. Alright, so in any of these methods of sexual abuse against children, a large amount of digital data or online data, such as videos, images, or any other document are getting created, which can be used by investigators as an evidence during their investigations. So now let's talk about a forensic investigation of sexual offense against children. So here we will basically be talking about two ways of doing that. So first will be examining child pornography videos in order to identify the scene or the area or the background where these pornography it should. So if the background or the scene or the location of multiple child pornography videos are same, then it clearly indicates that the video was created at the same location or in the same area. And if the investigator carefully examines the background, then the exact location may easily be identified, and further investigation can be done with this. And the next way of investigation is that suppose if investigators find multiple devices, for instance, laptop, desktop, pen drive, hard disk. So from these suspected, from any suspected location or from the scene for child pornography material creation, then analyze these devices to identify the exact device which includes these sexual abuse related content. So like the pornography video or the photos or any other document or the morph picture. So in today's webinar session, we will learn how to conduct digital investigations related to child sexual offenses by using forensic tools. And here we will be talking about basically two tools. One, we will talk about a tool, face forensics, which is a system basically developed to investigate pictures and videos of child abuse found on seized devices or seized hard drives or from other media and from the website as well. And second, we will be talking about a tool named CN Forensics. So which is a triage tool and used to forensically scan porn content and also generate a full report with respect to the obscene material present in any suspected device. So this tool is basically used to scan computer system for the traces or for any traces of pornography material on the suspected machine.
Good morning, Ian. It's a great pleasure to have you here with us. And welcome to our Forensic Friday. We have this every Friday, and we have a very large audience here of people who are really interested to hear what you've got to say.
Well, good morning, Samir, and it's a great pleasure to be here. I'm open to any questions that you want to ask me.
Great, thanks so much. Before I begin, let me introduce you to our audience. Everybody here, Ian Drummond is the CEO of Face Forensics. This is a company based in Canada, and his career has been spent in IT with a particular focus on security. Initially, he was working for the largest IT company in the UK, and then he became the youngest subsidiary managing director in the group at the age of 30. Where he ran, country operations in different parts of the world, including Malaysia, Egypt, and the UAE, and also spent a year in India. He was appointed president of the company's Canadian operations and subsequently was asked to run a Vancouver-based software company, Face Forensics, who has developed an arrest and booking system for the Royal Canadian Mounted Police. The RCMP had a problem when an offender refused to give their name when arrested, and Ian realized that face recognition was an ideal way to address this and employed 3 of Canada's top biometric experts to develop a solution. This was very effective and highly popular, and particularly in California, where their primary installation was and is the largest digital imaging and face recognition system on the US West Coast. This connected 32 police departments, jails, etc., with the ability to search over 2 million faces. Notable achievements include being contracted by the International Committee of the Red Cross in Paris to develop a system to identify the bodies of North African migrants who had drowned in the Mediterranean. It is possibly the only corpse identification system in the world. And other than that, his most important installation and what is relevant to us today is the development and design of ChildBase, which is the largest scene and face matching system of its kind in the world at that time. And this was developed for the UK National Crime Squad in London, now the National Crime Agency. And it was designed with the objective of identifying pedophiles and helping recover children who had been abused. This was, developed for the NCS at the request of the G8 and was launched at the House of Lords. It's been renamed to Child Scene, and it has been completely redeveloped to work with databases of any size, unlimited size, and it has the ability to link to different scenes, faces, and objects in them, even if cropped to a high degree or deliberately repixelated, thereby maximizing the information available to identify an abuser and recover the children. So thanks, Ian. Thanks once again for joining us on our Forensic Friday. And we look forward to, discussing a lot of things with you. Can I start with a question?
Carry on.
Thank you. So yeah, how did face forensics become involved in processing images of child abuse?
About 20 years ago, I was asked to take over as CEO of the Vancouver-based company, which was supplying the RCMP with an arrest and booking system. And they came back to us and said that they had a problem when they asked an offender their name. If they refused to give it, then what did they do then? So my chief technology officer had a master's in pattern recognition, and he, based on that, decided he could develop a face recognition system, and he did this. It was very effective, particularly in California, where numerous police departments used it, including at the largest police department on the West Coast, where they used it to match against 2 million images spread across police departments, jails, and other organizations within the law enforcement system. So that was how, and then what happened then was, I was at a conference in London, and the National Crime Squad had some people there. They'd heard about me, so they asked me what we do, and they actually contracted with us to develop a system to process the seized images that they'd accumulated. And the reason this had happened was that the G8 had asked them to do this because they had done more work in this area than anybody else in the world. They had more images in their database from seized hard drives. And so this was the place to go. They knew more about it, and they set up the child-based system at that time. It was launched at the House of Lords, and it went on to be a great success for them. And since, so that was really where we became involved in how the whole project started.
Fantastic. And what is the system designed to achieve?
Well, what it's designed to do, it's got two fundamental objectives. The first is designed to enable the police to identify and prosecute an offender, a pedophile, basically. And the second thing is that it's designed to help recover the children who are being abused in the shots and the movies that these guys are taking.
And there must be a lot of challenges involved in doing this. What are some of them?
Well, the main challenges in this are threefold, really. The first is that this problem is growing at an enormous rate, and therefore the volume of images that have to be compared with when you're trying to identify children or whatever is very, very high, and it's growing at an exponential rate. I'm in discussions with Interpol at the moment on this, and they say that by 2030, where there are 1 million there's 1 million terabytes of stills at this point in time. By 2030, there will be hold on a second. there'll be sorry, you'll have to edit this, but there will be 100 million terabytes of, sorry, it's 1 million terabytes of still images at the moment. There'll be 100 million by 2030. And in the case of movies of abuse, there'll be 1 million movies going to 10 million by 2030. So it's just a huge amount of data out there. And the reason for this, in part, is that abusers exchange their collection of images. So because they're all exchanging them, in those images, there can be very, very few that have been taken by this particular pedophile, but he's got just endless duplicates. They all have endless duplicates. So the volume can be up to, say, 99% images that are already known to the authorities. But the new ones are the ones that need to be filtered out, so that the police can focus just on those. So that's the core nature of the problem. That's it. Sorry, I'm just checking. Okay, hold on. So in order to do this, it takes. We take each image and we encode it in the same way that fingerprints or faces are encoded for matching purposes. We do the same with scenes. And there are techniques, there have been techniques for ages that allow you to do this, known as hashing techniques. And the issue with hashing is that hashing will match exact images. It matches the pixel pattern of an image. But you change a pixel, then they won't match. And of course, pedophiles know this. So what they will do is they will use pixelation editors, they will crop images, they will resave them in a different format, whatever, so that the pixel pattern doesn't match. And so what we have to do is to have a process where we can actually match the characteristics of the image, where lines cross, specific colors appear, relationships between objects are known and can be found, in order to match images that may actually look different, particularly when they're cropped, from the original, but we can still put them together. And we can, and in our case, we can do this up to 80 to 90%. So there's only 10%, can be only 10% left in a number of cases, and we'll still match it against the original. So there's a strong emphasis on partial matching here, but in addition, beyond that, we can match SMT, scars, marks, and tattoos, which will differentiate the individual. So if he's got, let's say, a tattoo in his arm or a particular scar, then we can say, okay, we're looking for that particular scar as part of the matching process. And beyond that, I remember in one case, the National Crime Squad were able to link a number of images together, because there was a Coca-Cola bottle that was sitting on a coffee table in a hotel room, and that was able to, as I said, link those images, and each of the images may have more or some different information in it, and from that they were able to identify the offender. We can even take this into clothing. So if you're wearing a medium blue jacket, for example, then we can look for medium blue jackets. So anyway, and so on, and obviously face recognition as well. Now, with faces are a real challenge, because of course the children in these shots are not really looking at the camera just in a classic sort of family shot style, and so you're working with very often very upset children, and from angles that are not conducive to being matched. So there are major challenges in that area as well. But by all of this, and particularly by the fact that we can match up to 80 to 90%, so we match up to, or down to 10 to 20% of an image, we can take those images, if you like, off the table, leaving the investigators to just focus on the ones that haven't been seen before. And the associated major benefit in that is that doing that investigative work is highly traumatic, and the fewer images that the investigators have to look at, the better. So what we're trying to do here is automate the process as much as possible, take the people out of it as much as possible, let them focus just on the ones where they can be most productive, and move on from there. So that's basically what it does. We've designed it so that there is no limit at all to the size of the database, the master database, if you like, that can be matched against. So we're never going to run out of capacity, and hopefully it will enable law enforcement to get a hold onto this problem, and in the future be able to clamp down on it more easily.
Yeah. It's such a heinous crime, anything that we can do to make it better is something that we must do. What functions does child scene, what functions does the child scene system provide?
Well, as I said, it amalgamates a number of different matching technologies, some of which we believe are unique to us. So I mentioned scars, marks, tattoos, objects, material, and in complete fashion or in partial fashion. So we're offering or providing as many capabilities as possible to identify the abuser, who does not ever want to put his face in an image because he doesn't want to be identified. And this enables or will help the authorities actually work out who they are.
Sure. So how successful has it been?
Well, as I said, it was very successful at the National Crime Squad, and we are in various discussions at this point in time, but we know that it works, and of course, with any of these recognition technologies, there are always gray areas where the image may be fuzzy, it may be long distance, it may be at strange angles, it may be at bad lighting, a whole bunch of things like that. And in looking forward now, really it's those compromised environments which we want to make it better and better at. So with all biometrics, it's like that, to be honest. So that's where the focus is.
Got that. So where do you see the technology going from here?
Well, as I said, it really from here, it's going towards just everything being done better. And as I touched on, I think every biometric would say the same. Take face recognition. They wanted to work further away, lower resolution images, worse lighting, difficult angles. These sort of things are where the challenges are these days.
Right. Yeah.
Yeah.
That's great. Thank you, Ian. Thank you for your time. I know, we've got you up at an early part of the morning, and we're getting a lot of inputs from you. We're grateful. What I'm now going to do is I'm going to now switch over to a video which shows us child scene in action, which will give us great insight into what child scene does. So thank you very much for your time, Ian. We will be in touch again, and perhaps with a lot of questions. Thank you.
My pleasure, Samir. My pleasure. Thank you. Bye for now.
Bye.
This is an updated non-public demonstration of Child Scene, a system designed to process still and video images of child abuse on seized hard drives, other media, online, and on websites, by comparing the images, even if heavily cropped or modified, against a central database of known images of abuse. This enables new images to be separated from known ones to a much greater degree than previously available, substantially reducing both the time to process a seizure and the potentially traumatic effect on investigators. Child Scene then uses our AI-based face recognition technology to help identify the children. It builds on our team's earlier experience in developing the child-based system for the UK National Crime Squad. This was launched at the House of Lords in London and was the largest system of its kind in the world at the time. Traditionally, hashing techniques have been used to find identical images by matching pixel patterns. However, this doesn't work if an image has been cropped or deliberately modified. Child Scene's algorithms solve this problem. All the images you'll see in this demo are innocuous and also generic. They're not associated with the subject matter in any way. We're looking here at the main screen where searches are handled. The tabs across the top offer the ability to search existing databases of images of abuse, offenders, offenders' tattoos, victims and objects, and where possible, detect links between them. In each case, the images in the database can be viewed or a search can be initiated of them. We can see examples of the scenes we'll be searching by clicking the Scene Database tab at the top left. And the control at the bottom allows us to scan through them one by one. So I'm going to go back to the Scene tab here and drop in an image of a room. So this is notionally from a seizure, and we drop it into the area on the right. Child Scene immediately encodes it by finding distinguishing characteristics and using its algorithms to convert these into a numeric encode array unique to each image. When we compare images, we actually compare encode arrays. The arrays themselves can't be reversed back to images. So when I click on the Recog button on the right, the encode array of the image will be compared with all the encode arrays in the database of previously seen images, and thumbnails of the top matches will be displayed in the area on the left. So any image can be quickly checked to determine if it's been seen before. At the top left is the probe image we want to search the database for, followed in this example by the top match and then 2 medium cropped matches. The 5th match is of the heavily cropped table lamp. These cropped images are a major challenge because the cropped area could be any size, anywhere in any image in the database. Despite that, it still finds them correctly. So that's an example of a full image finding heavily cropped parts of itself. Let's reverse this by matching a heavily cropped image against full or less cropped versions of it. So here's a substantially cropped image. I'm just going to drop it in. It's of the same room. In fact, if you look at the matches from the previous search, you'll see it's really that top corner there. And when I click the Recog button, 3 of the top 4 matches are of the correct room. So full images can find cropped ones, and cropped images can find full ones. In the next example, the seized shot is taken from one side of a room, while the database shot is from the other. Let me just drop that in. For good measure, the database image is a JPEG and the probe is a PNG, so they're also very different compression formats. Let me just click Recog once again, and you'll see that both database images are identified, and even although they're from different angles, they contain sufficient common characteristics to match well. The next example is an image of a hotel room which has been cropped by about 90%. So we're seeing just 10% of the original, and once again, if I click Recognize, the match is this image here, and you can see the area that we're matching against right in the center left at that point. It's worth noting that the smaller the crop, the less detail that Child Scene has to work with, and therefore there's a greater chance of it being further down the match list. Child Scene can also be used to match fabric colors and patterns. Earlier I mentioned face, tattoo and object recognition. Here's an example showing tattoos. While an offender's face may not appear in any of the images, tattoos on his arms or elsewhere may be visible. Now if I switch to the tattoo module up on the top tag there, drop in a cropped image of a scorpion and let it encode, and then click once again the Recognize button, Child Scene will match it against all the known offender tattoos and find and display the full image with details of the owner. Similarly, the victim module can be used to match victims' faces against databases of missing or abused children. So recognizing something in one module can lead through the other modules to potentially identify offenders through their tattoos and victims, and linking different cases of abuse to the same offender. ChildScene can link instances of the same location being used to abuse different children, very likely by the same person. If some of the pixels in an image have been modified to avoid hash-based searches, ChildScene will find them regardless. While this video has focused on individual seizures, in conjunction with law enforcement, ChildScene can also be used within external organizations to detect full and heavily modified images of abuse passing through their servers, without the content of the images being seen within the organization. So that's a brief introduction to ChildScene. It's a highly effective means of distinguishing known from new images, even if heavily modified, helping recognize child abusers, helping identify and rescue children, collapsing the time required to process a seizure, and substantially reducing the trauma experienced by investigators who have to view the images. We'd welcome the opportunity to show you what it can do. Copies of ChildScene can be provided to law enforcement agencies for evaluation and testing with full online support.
All right, so most of the things have already been covered in this video. So there are a number of things that F2 can be used for, such as the prevention of child sexual exploitation. So first thing that F2 can be used for is identifying videos or pornography videos found on the evidence media, which are already present on the existing database. So suppose these child pornographers have tons of videos on their hard drives or on their phones. So if we are analyzing these data and we found that out of 10,000 videos or pornography content, 9,986 are already present in the existing database, then we will not waste time in seeing those videos which are already present in the database, because seeing so many videos can be very disturbing for the investigators because it affects the mental well-being of the investigator. So it makes sense to reduce the load of the examiner to the extent it is possible. And so in this situation, what one does is that one will look only at those remaining 14 videos, those remaining 14 new videos. Now from those 14 videos, some may be pornographic videos, some may not be the pornographic videos, and some may be the child pornographic videos or the child pornographic content. So if they are child pornographic content, it again gives us a clear-cut indication that these are new videos which are not in our database, and they may have been created by the suspect or the criminal recently. Now F2 can then be used in identifying faces in that videos and match them against the missing children database and identifying those children that have been kidnapped recently. And the second thing that it can also do is to identify background using child scene and see if the background or the scene matches with the other videos, to see if the same location or the same perpetrator, and again this will give us insight for an investigation perspective, that where these kind of videos are getting made. So the investigator will get the clear-cut idea that what is the place where these kind of stuff is getting prepared. So this will help us focus our effort and direction in identifying exact location where this kind of material is getting prepared. So I think that this gives us a good insight into what we can do with F2 in investigating offenses related child sexual abuse. And also it is very important to quickly identify the media which contains these kind of material like videos or the pornographic images or any other document, pornographic related document. So for that we have with us here Stewart, and he is heading CN Forensics. And CN Forensic is a UK-based company, and they have some path-breaking technology which speeds up the process of identifying media with CSAM material, basically child sexual abuse material, so that you can quickly, within a few minutes, can go through hundreds of hard drives and say that these contain material of interest. So for the investigator, it is very, very important to get to know about these. And then you can focus your attention and not look into unnecessarily hard drives. So now with this, I will hand over the stage to Stuart for further things.
Okay, hopefully you can see my slideshow. Is that correct? Do you see that, Sam?
Oh, yes, absolutely.
Brilliant. Okay. Good morning, ladies and gentlemen. Thank you for the opportunity to speak with you this morning. My name is Stuart Hutchinson. I'm the VP of Sales for, we were CN Forensics. We changed our name last week to Siacombe for a variety of reasons. And today I'm here to talk to you about a couple of our products, which, as we mentioned, will allow you to identify child sexual abuse material on hard drives or mobile devices way quicker than you've ever been able to do before. So let's begin with a couple of introductions. Firstly, myself, I was a police officer at Scotland Yard for 23 years. Most of my work was in digital forensics. I was responsible for starting the high-tech unit for the Counter-Terrorism Command at Scotland Yard. I did a load of high-profile investigations whilst I was a detective, including investigating into the London bombings. We did a lot of work around the London 2012 Olympics. And about 9-10 years ago, I moved into the corporate space, where I headed up sales and training for companies such as Black Bag Technologies, who are now part of Celebrite, and more recently Oxygen Forensics. So I joined Siacombe in January of this year. The company itself has been in existence for about 5 years. We supply 3 products to law enforcement globally at the moment. You'll see our flagship product this morning, Siacombe Examiner. It's rolled out to every police force in the United Kingdom. So every UK police force has multiple copies of this because of its effectiveness in dealing with child sexual abuse material and their CSAM investigations. The biggest issue, or one of the biggest issues that law enforcement face when dealing with this kind of investigation, and it's not just child sexual abuse material, but we will focus on that today because obviously that's the purpose of the webinar, but in general is the amount of digital evidence that is involved in investigations generally. Speaking from a UK point of view, I can't think of any investigation nowadays which doesn't have a digital component to it. And the problem that investigators face globally is obviously the amount of data stored on those devices is increasing exponentially every year. When I started 21 years ago, hard drive sizes were, 100 meg, if that. Now we're talking about multiple terabytes of data, and if not more, coming up in investigations on a regular basis. And the problem is the amount of time it takes to investigate that data. And those delays can have catastrophic events, especially in the child sexual abuse material kind of investigations, because these kids are real victims. And the longer it takes to identify those children, the longer it takes to prosecute those offenders, means that the suffering endured by those kids goes on and on and on. So what we have developed is a digital forensic triage system, which allows you to really quickly and easily sift through a huge number of devices in a very short amount of time and identify which one of those devices contains child sexual abuse material and is therefore warrants going forward for a full digital examination. The reason that we have been moved into all of the UK police forces is they have a huge backlog of casework. Some forces are reporting that their casework backlog is 6, 9, 12 months worth of work. And the problem is, of all of those digital devices seized that are sitting in their evidence stores, it's difficult for them to quickly identify which one of those contains evidence of child sexual abuse and therefore move those forward in their investigation and prioritize first in order to identify scenes in order to prosecute their
Stuart, your voice is breaking up.
Amount. Sorry, Sammy. Is that any better?
Yes, it is now.
Sorry about that. So we've been brought in to help them reduce the amount of backlog within their caseload. Our technology can be used in a variety of different ways, both within a lab environment and also on scene. A lot of our investigators go out on scene and go into addresses where not only are there multiple people within those addresses, but there are multiple devices as well. Some of those devices are completely innocuous. Some of those devices will contain illicit material. And what our technology allows you to do is quickly and easily go through those devices at the scene of the crime and identify which ones warrant further investigation. If we're talking about a family home where there may be parents, multiple children, it's important to identify which one of those devices is worth bringing back to the lab. Many police forces will not have a choice. They will have to seize everything within the property. But the problem is with that, they're just adding to an already extensive backlog. So by using the digital forensic rapid triage at scene, we can identify which one of those individual devices warrants bringing back for a full investigation. So even before we've got to the lab, we're reducing the backlog to machines that are worthy of our further investigation. In addition to that, it allows us to quickly and easily identify the individual responsible for that material. In a family home, it could be the father, it could be the mother, it could be adolescent teen, but by identifying the material that contains that material quickly and easily, we can identify suspects that way as well. And again, all of the scene. In the UK and elsewhere in Europe, we have specific police officers that are responsible for managing known sexual abusers who are out in the community. And again, this is one way where our technology really assists. With other technology on the market, it can take several hours to fully examine that individual's laptop to confirm whether or not there is material on there. With our technology, as you'll see shortly, we can cover a huge amount of data, a huge amount of devices in a matter of seconds in some instances. So these visits are a lot easier for our officers to undertake, and we can identify whether there is any reoffending, as I say, within a matter of seconds. Whilst we are concentrating on child sexual abuse material today, we have multiple other use cases, and I'll speak to you about the kind of technology that we're using and how we're able to do this. But we're also seeing a huge amount of success with this at our borders and ports here in the UK, and our counter-terrorism officers stationed at Heathrow and Gatwick and our major seaports are also using this not only to identify child sexual abuse material, but other criminal material that may be found on digital devices. So it's not just child sexual abuse material where this technology can be used. So let's give you a very quick demonstration of our SciComm Examiner tool. This is the flagship tool. It's designed to be used by forensic practitioners within their lab environment. If I just cancel my PowerPoint and open up Examiner. Sam, can you just confirm that you can see the tool on the screen? Perfect, thank you. Okay, so this is Cyan Examiner. It's designed for digital forensic professionals, albeit it's not very difficult to use. As you can see, it's a fairly intuitive interface. Let me explain a little bit about what we've got set up here. On the left-hand side, we have a list of devices that are plugged into my laptop at the moment. I'm running this demonstration on a Microsoft Surface. It's got an i5 processor, it's got 8 gig of RAM, and into that I've got a USB hub. That USB hub has got as you can see here, a USB thumb drive in it. It's got a 75 gigabyte spinning hard drive attached to it, and it's also got a 120 gig SD card that's plugged into the Microsoft Surface. So this area here allows me to choose which devices plugged into my laptop, my lab machine, if you like, I'm going to analyze with Examiner. So I've picked the 3 external ones. So today we're going to be going through about 200 gigabytes of data, looking for illicit material. For the purposes of the demonstration, we're not going to be using actual child sexual abuse material. We're going to be using pictures of space travel. What I need to do is I need to load in what we call a contraband filter. Now, our contraband filters are stores of known illicit material. I'm going to load in our space travel one. It contains a huge list of data relating to pictures of space travel. From a CSAM point of view, this would be your national child abuse database converted into one of our contraband filters. So we've loaded that in. I now need to select a configuration. We'll talk about the technology in a moment once I've shown you the demonstration, but I'm going to pick a 99% confidence rate. So that means I'm going to be 99% confidence once I've scanned this media, that there is either going to be child sexual abuse material, or in our case, space travel on there, or there's not. And we'll talk about confidence levels, as I say, once I've shown you the demonstration. Then all the officer has to do, the investigator has to do, is press Start Scan. Over here, you will see a roundel, and within that, if there is any space travel material detected, it will turn red. If there's no space travel material detected, it will turn green. To put this into context, if I were to be searching 210 gigabytes of data using an alternative tool, this process would take anywhere between an hour and 90 minutes. I'm going to hit Start Scan now, and we'll see how long it takes to turn red. It's already turned red. We haven't actually been running more than 4 seconds, and we have detected child sexual abuse material on our thumb drive. We have also detected child sexual abuse material on our SD card, and we've also detected child sexual abuse material on our 80 gigabyte spinning hard drive. 4 seconds is how long it took us to detect that. I can then start looking at the results. We have 3 tabs here, one for each of the pieces of material we have seized and we're examining. This is our thumb drive. And here we can see that we have detected multiple blocks of data on that thumb drive that contain child sexual abuse material, in our case, space travel material. What I'd quickly like to do is just open up this thumb drive in Windows Explorer. It's an empty thumb drive. We're not only detecting this material within a live file system, but we're also detecting this material that has been deleted from that media as well. If I come across to our spinning hard drive, again, we're detecting images. We will tell you where exactly that image is and its physical location, but you're also able to double check our filters by previewing the image. If we click on this button here, it will show us it's a picture of space travel. Once the scan's finished, and again, this probably for the 200 gigs that we're processing at the moment, the scan's probably going to take about 3.5 minutes to run, but we can create a report. We just add some details in. Click OK. Tell us where it wants to save it. And we'll quickly generate a PDF report. We can then open that report and all of the details. Firstly, it tells us that we have detected that material. And then as we scan down, it tells us where all of that material is, the file names, and in the case of deleted data, the physical location, the physical block location of that data on that particular piece of media. So we're 3 minutes in, we've scanned 200 gigabytes of data. We found illicit material on all 3 pieces of that data, included deleted stuff, and that whole process, 210 gigabytes of data in 3 minutes. I'm going to close that down. I'm going to return back to my PowerPoint, and we'll spend a few minutes talking about the technology and how we do this. Examiner and our other tools work slightly differently from other technology that's available. We use a combination of what's called block level hashing and statistical sampling to rapidly identify material on a hard drive or a mobile device. This is backed up, this technique has been backed up not only by field trials in police forces around the world, but a huge amount of academic research as well. The technology was developed by Edinburgh and Napier University and has been verified by the UK Home Office. Not only will be being used in organisations such as the Met Police in London and the FBI in the US, but it's also been looked at by a number of other academics in different universities. Block level hashing is the key to this. It gives us a huge amount of advantage, both in terms of speed and functionality. You're all familiar with file hashing, so MD5, SHA-1, SHA-256. With a file hash, we need the entire file. We then run our algorithm, be it MD5 or SHA-1, across the entire data contained within the file. And that allows us to create a digital fingerprint for that file, which allows us to identify other instances of that file on other pieces of media. If we change the file name, doesn't make a difference because we're only running that hashing algorithm across the entire file. We're ignoring things like metadata. It's only the digital, the data content of that file that we are fingerprinting, if you like. The issues with standard MD5, SHA-1, SHA-256 hashing is you need the entire file. So if the file is fragmented on the disk, the file has to be recombined before the hash algorithm can run across it. In addition to that, you have to have the complete file. So if the file has been deleted and partially overwritten, an MD5 or SHA-1 or SHA-256 hash won't find that data. So you're automatically restricted on where you can search for that file and how long it takes for that file to be found. With block level hashing, we break the disks down into its physical blocks, and we create a block, a hash for every single block. So the file, when it's placed on the disk, is broken down into those blocks, and we don't hash the entire file, we hash every block in that file. That gives us huge advantages. It allows us to find results faster, as you've seen, 3 minutes for 200 gig of data, because we don't need the entire file. As long as we can find one block that matches one hash in our database, we will find a positive result. Now, our technology has got some specific algorithms built into it, which allows us to reduce the amount of false positives. I'm sure you're thinking, well, if you're only partially, or if you're only hashing a single block, the likelihood of that block arriving or being present in multiple places on that disk is quite high. And you're right, it is. However, we've got a number of routines built in, which would then, if we identify a block that contains that illicit material, we search the blocks either side, and we've got some mathematical algorithms that mean we can rapidly discount false positives. The other huge advantage with this, as it says on the slide, is we're not bothered whether the file has been deleted or not, or whether the file has been partially overwritten. We can still detect that material even if the individual has tried to get rid of that evidence. The other huge advantage is even if the entire file system has been damaged, so if they've heard the police arrive during the entry to the premises, someone has tried to format their drive, again, we're not bothered. As long as we've got access to any data on that physical piece of media, we can identify illicit material from there, because we're not bothered about whether it's a file or not, or whether it's in its entirety or not. We also use a method called statistical sampling. We are not going to start at the beginning of the disk and run all the way across the disk. There's no need for that. We will dip sample the disk based on our patented mathematical algorithms to ensure that we can accurately, but more importantly, rapidly look at every piece of the disk. We've replaced conventional MD5 hashes and hash lists with what we call contraband filters. So a contraband filter takes the existing material and converts it into those block hashes I've been talking about. These are even more secure and efficient than MD5 hashes. You'll be aware with something like an MD5 or a SHA-1 hash, you can't get back to the original file. It's the same with our contraband filters. But the difference is, with an MD5 hash, if your MD5 hash list gets out into the wild, so you have, let's talk about child sexual abuse material, you have a huge list of MD5 hashes of known child sexual abuse material. If those lists get into the public domain, people can use those MD5 hashes to search on something like BitTorrent to find other versions of those same files. With our technology, it's not possible, because none of our contraband filters contain a hash of a single file. They only contain a hash of linked existing blocks within those files. It's a one-way process. You can't reverse engineer it. Even if you had the entire contraband filter, you can't get back to the original files. Let's talk about some of its capabilities. At the moment, Cyan Examiner runs on Windows. We are working on a Linux and a Mac version, but at the moment it runs on Windows. As long as Windows can see the media, be it a logical volume, be it a physical disk, be it an EO1 evidence file for something like FTK Imager or Encase, we can scan it. If Windows can see it, we can scan it. We're not bothered about file systems or partitions. If you can plug a Mac into your examination machine, we can scan the Mac. As long as the Windows machine can see the NTFS, the HFS or the AFS file system, we can scan it. We're not bothered, because we're not looking at the data as a file system or as an individual file. To us, we're just looking at it as a physical block of data. If it's an unknown file system or the file system has been damaged, the process is going to take slightly longer. This is because our statistical sampling algorithms are based around all of the main file systems. So we know how Windows lays data down onto a disk. We know how the Mac Apple operating system lays data down onto the disk. We know how Linux lays data down onto the disk. And so the algorithm uses that information to do the statistical sampling in the most efficient way. If the file system has been damaged, we need to do a more comprehensive statistical sample. So it will be slightly slower, and obviously you will be warned that 10% or more of the disk has been damaged. What can it look for? It doesn't matter. As long as you've got the original file, we can create a contraband filter for it. It doesn't matter whether it's a Word document, a PDF, a movie, a JPEG, PNG. The system doesn't care. It just needs the original file in order to build the block hashes for it. In terms of formatting, in terms of previewing, yes, all of the main file formats are covered. But if you've got some new or unusual file formats, then obviously we can, as long as we can build the contraband, we can find it. We just might not be able to preview it for you. As I've mentioned, we'll work on live data in the live file system. We will work on stuff in the recycle bin. We will work on deleted. We will work on deleted overwritten. We'll work on through unallocated space. From our systems point of view, they're just blocks. They're physical blocks of the disk. So it doesn't matter whether that data has been deleted or not. There are three different ways in which this will work. I've shown you it as an installed application on my lab machine. This is probably the most forensically sound way of doing it. It's also bootable. So if you've got a Windows system, you can boot directly to our thumb drive, start it up and scan the internal drive. But it'll also work live. We've got a very specific tool that works on live systems as well. Installed mode, it's forensically sound, and obviously you may need to remove the drive if you can't get it. Today, I've scanned that 80 gig drive through a write blocker, so it doesn't really matter. Bootable, again, slightly less sound. There is no need to remove the hard drives, but you do need to have the technical ability to boot that machine into our forensically sound environment. And finally, live mode, ridiculously easy to use, as long as you can basically plug our thumb drive into a live running unlocked machine and start the application and press the start button. That's all you need. It can search through types of encryption, such as BitLocker, as long as that encrypted drive is mounted. Needless to say, the disadvantages, it's not forensically sound. We're talking about live triage and live forensics now, and it will make some changes to the suspect's computer. If you require, we can provide you with a full list of all of the changes that our application makes to that suspect computer. So whilst it's not essentially forensically sound, we can at least tell you where the changes are, and you can use those to obfuscate any questions within a trial or whilst you're being cross-examined. So just to summarize that, in our lab environment, it's completely forensically sound. It's going to go through a write blocker and you're not going to make any changes. With bootable, again, it's relatively forensically sound. We've got a forensically sound operating system that we boot to on our thumb drives, and it allows you to access those drives without the need to take the drives out. And finally, we've got our live system, which was basically for on-site triage or voluntary search, and we'll make some changes, but we can identify and we can tell you all of those changes.
Okay, I have a question while we wait for other questions. When you are doing an investigation, and now at the moment we are only talking about CSAM material, but this can be done with anything, like say for counter-terror investigations or anything else. Is that correct?
Absolutely anything else. It's being used in the UK for things like counter-terrorism, fraud, Anything where you need to identify even a single file really quickly. Because we're dealing with things at a block level, the actual file type that you're looking for is to a certain extent irrelevant. As long as you've got the original file, it's being used in sensitive investigations over here where, you've got highly sensitive documents that maybe have been leaked into the public domain, and we need to quickly and accurately track where those have gone. So yeah, there's a huge range of other possible use case scenarios. Obviously today we focused on the child sexual abuse material stuff.
Thank you. So it can be anything, just about anything.
Absolutely anything. Yeah, if it's a file on a system, we will be able to find it.
Excellent. And what about mobile phones? Suppose, there's a lot of data on mobile phones today, data that is stored on, handheld devices, for example, and people tend to use those more than computers.
Absolutely. If I just reach behind me, 2 seconds. We have the same technology on this, which is a Data Pilot DP10, and it's designed for doing exactly the same thing with mobile devices, both Android and iOS, tablets and phones. So basically you would plug the suspect phone into this device, and it will allow you to do a cyan or a cycom scan on it. And again, it gives you the option to do some other things as well, and do a slightly deeper dive into the phone. So it's a Data Pilot DP10, and we supply it with the same technology on it, so it covers mobile devices as well.
And how fast is it?
It's slightly slower, but when I say slightly slower, you saw with the computers, it took 3 seconds. With the DP10, we're talking about 30 seconds. It's because of the way that the data is stored on the device. What we do is we create a virtual disk of the contents of the phone, and then we scan that. So the creation of the virtual disk may take about 20-25 seconds, and then we run the scan over it, and the scan speed is essentially the same, but there's a little bit of an overhead to begin with because we need to get the data off of the phone or start accessing the data on the phone.
Got that. Thank you. Thanks very much.
No problem.
सर नमस्कार। सर मेरे 2 क्वेश्चन है सर। पहला सर, जिस तरीके से पेंडेमिक सिचुएशन आई थी और इंटरनेट जो है सबको अवेलेबल हो गया, छोटे बच्चों को जैसे ऑनलाइन क्लासेज हुई उनको प्रोवाइड किया गया और उनको मोबाइल दिए गए, जिससे सर एक सिचुएशन हुई कि उनके पास इंटरनेट इजी हो गया, जिससे वो गूगल पर चले गए, यूट्यूब पे चले गए, यानी कि उन पे एक कंट्रोल नहीं रहा, जिससे उसको कई ऐसे मटेरियल अवेलेबल होने लगे। तो पहला ये है कि उसका ऐसा अलग प्लेटफॉर्म हो उनके लिए जहां पर इस तरह के मटेरियल उनको नहीं मिले। सेकंड है कि कई जो है पोर्नोग्राफी है, ये जो कंटेंट अवेलेबल होते हैं, तो उनको प्रिवेंट करने के क्या उपाय है?
देखिए, 2 चीजें हैं। सबसे पहले क्या है कि एक आपका पेरेंटल कंट्रोल, मतलब ये घर से कंट्रोल हो गया, और दूसरा गवर्नमेंटल कंट्रोल, जो गवर्नमेंट से कंट्रोल हो गया। पेरेंटल कंट्रोल में क्या है कि ये सब जो है ये ब्राउजर से एक्सेस होता है, तो ब्राउजर में फीचर होता है पेरेंटल कंट्रोल का या सेफ्टी फिल्टर का, जो मतलब नॉन एडल्ट कंटेंट रोकने का। तो आप लोग एक पासवर्ड लगा के इसको रोक सकते हैं, और वो ये अवेयरनेस बढ़ाने की बात है। आप यदि अपने एरिया में कर रहे हैं, सबको मतलब जागरूक कर रहे हैं, तो आप ये करिए, तो दे विल बी मोर अवेयर और वो बचेंगे। सेकेंड पॉइंट जो है वो है गवर्नमेंटल कंट्रोल्स का। गवर्नमेंट ने अपनी तरफ से काफी पाबंदियां लगाई हैं जो लोगों को रोकने के लिए कि भाई आप मतलब जैसे पोर्नोग्राफिक साइट जाना है तो वो कहेगा दिस साइट इज ब्लॉक्ड, और इस तरह के मैसेज आएंगे। परंतु आज की डेट में बच्चे ज्यादा सियाने हैं बड़ों से, तो उनके पास VPN वगैरह का पूरा वो होता है एक्सेस, और वो उसको यूज करके बाईपास कर लेते हैं, तो ये दिक्कत आती है। लेकिन अभी स्थिति ये है।
जी जी सर, इसमें जैसे कई बार कंटेंट मिलते हैं, तो उन कंटेंट के जैसे मेटा डाटा से ओरिजिनेट तक पहुंचने का क्या रहता है कि कई ऐसे कंटेंट होता है जिसमें ये नहीं पता चलता है कि ये कहाँ से रूट हुआ है, कौन है इसका, तो सर इसके IP से इस तरीके से ओरिजिनेट का पता करने।
नहीं, अब ये सवाल इतना क्लियर नहीं है।
नहीं सर, कई कंटेंट जो होते हैं सर, जो नेट पे अवेलेबल होते हैं, कई ऐसे हैं साइट है जैसे डार्क वेब में है ऐसे कंटेंट है, तो इजीली उसके ओरिजिनेटेड का पता नहीं चलता है कि वो कहाँ से ये अपलोड कर रहा है, सेंडर कौन है इस रिगार्डिंग।
डार्क वेब तो बना ही सीक्रेसी के लिए है। तो क्या होता है कि डार्क वेब में जो मटेरियल है वो अनियन साइट्स या जिस पे भी अपलोड करते हैं वो इसलिए करते हैं ताकि आप आसानी से ट्रेस ना कर पाए। तो ये कहते हुए कि भाई ट्रेस नहीं कर पाए वो मतलब कठिन बहुत ज्यादा है, लेकिन क्या है कि अगर पूरी फैसिलिटी हो, एंट्री और एग्जिट नोड्स पे मॉनिटरिंग हो, तो कुछ समय और मतलब परमिशंस हो ये सब करने के लिए, क्योंकि हमारे पास ये लीगल नहीं है कि हम एक्ट करें जैसे हम चाइल्ड पोर्नोग्राफर हैं। अगर हम कुछ करें और उनके ग्रुप में शामिल होने की कोशिश करें, इन्फिल्ट्रेट करने की कोशिश करें, तो हम जो कर रहे हैं वो अगेंस्ट द लॉ है, हमारे देश की लॉज के बिल्कुल विरुद्ध है, एंड इट इज फॉर वी कैन बी अरेस्टेड फॉर दैट। सो द की थिंग इज कि कई कुछ चेंजेस लाना आवश्यक है और उसके बाद ही ये सब हो सकता है। आपका म्यूट हो गया है।
सर ऐसा मैगजीन नहीं तैयार किया जा सकता जिसमें इसमें प्रिवेंट किया जाए?
हाँ जी,
एक मैगजीन तैयार किया जाए जैसे ऐसे कंटेंट अपलोड हो जिसपे रोका जाए।
देखिए ये अभी तो सीबीआई के परव्यू में है, वो सब यहाँ पर हैं, साथ बताएंगे कुछ। राम गोपाल सर।
Good morning, Samir ji, and good morning to all. Like this tool, SciComb, of course, not only for child CSAM material for decoding the seized devices for CSAM material, it can be used for many other investigations, as he has rightly said. So, is this system available in India, first of all?
Yes.
And if yes, whether the hardware version is there or on the software version is also available?
A hardware version is has not come yet to India, but it can be brought.
No, but as he was showing, like for mobile devices, he was showing a hardware device to which the mobile has to be connected.
So that is currently in the UK. So one can get a unit. अभी मंगाया नहीं है.
And in India, software version is available.
Software वाला तो हमारे पास पड़ा भी हुआ है. We have,
okay,
but the hardware one, I mean, one can buy it and get it.
And the online mode he was telling about, that time I had some network issues, so I could not attend to that part.
Yeah.
And in the online version, the contraband filter which he was talking about, if a database is available online and we want to compare it with the seized devices, is it possible, or we have to first like have full access of the database on our computer itself?
See, the problem is that this database of CIAN is different from the Project Vic type databases. Project Vic and all, they will work on huge hash values that they have collected over the years of a lot of child CSAM material and things like that. What this works is that their hashes are different. That is how they are able to even identify deleted and overwritten and partially overwritten files, which others cannot do because their hash works at a block level rather than at the full file level. That is how they are able to save time and also identify these. So there will be a conversion process. You will have to take the original files, create the hashes to the CIAN's hash set, and then after that, then the original files are no longer required, only the hash set can be shared to all the departments.
No, my question is this contraband filter.
Yeah.
Like it is inbuilt into their system, or like we can have our own customized contraband filter, not customized, we can have our specific set of say videos or pictures as our own contraband filter.
You can create your own contraband filter. You can import a contraband filter from somewhere else. By default, they give you the ability to create your contraband filters. They don't provide you contraband filters, but one agency can take it from another. So suppose you are in touch with, say, Metropolitan Police, for example, in this thing, or you're in touch with their CSAM officer here in the embassy, and you say, look, we need this filter, they will just share it with you. And you can import it into your system.
Okay, right. Thank you so much.
Create your own. India specific can be created also. 5 videos. 50
like for
videos.
example, for example, in some other case, like a traditional murder case or something, like he was saying that some leakage of documents is there. We want to just search some say 100 devices in which this particular document is there available or not, a copy of that document. For that, we can create our own that contraband filter.
Yes, it can be done, and it can be done very fast, instantly. If you need help with it, just let us know. We will help you.
Okay.
This is like instantly doable.
Right. Okay. Thank you so much. Thank you.
Welcome. Welcome. Okay. Then we have Mr. Chandrakant.
Good morning, sir.
Good morning.
Good morning, sir.
Yeah. Good morning,
Sir,
Chandrakant.
first upon, I should congratulate you. You are looking very smart today.
Thank you. So kind of you.
Sir, I have two queries. First upon the psychocam, whatever presentation has been shared by the Stuart, his English was so high, and his some lecture is go upon our head. So I will write to request to share his all data on the WhatsApp as a PDF file or whatever in the data file. So we can study it. Yeah. After which we can study it properly. I have one request also. During this cyber fraud, we are going to the banking cyber frauds and all these things. So I'd like to request you to put on some lectures on that cyber fraud also, how to prevent it properly. And it is today's course that madam has spoken about the POCSO cases. I am the first police officer in Maharashtra who initiated first POCSO Act in 2012 and got first conviction in that case.
I think that is a great and commendable feat. Everybody should, appreciate this. Congratulations.
Yeah, and
Mr. Bosle.
many other several cases I got a conviction. So POCSO Act is nowadays very helpful to us. And my another request is the forensic DNA profile. What is the DNA profile? How to go this thing and send it to FSL. इसके बारे में भी एक लेक्चर आप अगर करेंगे, एक कोर्स में कुछ करेंगे, तो I'll be thankful to you. Thank you. Have a good day.
Thank you. Subhashini, please make a note of these so that both these points, they are very good points, so that we can later on put one of the lectures on that, one of the Fridays.
And thank you, sir, for suggesting topics for Forensic Friday webinars. So one is forensic DNA profile. If I'm correct, please let me know.
Yeah, DNA profile itself, and how to send it to FSL immediately, and then cyber fraud, banking cyber fraud.
Okay.
Thank you.
Professor Narayan Bhosle, can we have you, sir, on the?
Yes, sir.
Yes.
Sir, good afternoon, one and all, and especially Samir, sir, and for the opportunity.
Good afternoon.
A nice and very wonderful session. Sir, I would like to just ask one query. जब भी हम ये एविडेंस कलेक्ट करके उसकी फाइल जब बनाते हैं, तो मान लीजिए MD5 या SHA 256 ये एल्गोरिदम हम यूज करते हैं और उस डेटा को कंटामिनेशन होने से बचाते हैं। तो जब भी हम कोर्ट में जाते हैं, तो फाइल का चेन ऑफ कस्टडी कितनी बार मूवमेंट हुआ है और कौन से बार कुछ कंटामिनेशन नहीं आया, उस की को हम मतलब उस एल्गोरिदम से जो की जनरेट होती है वो चेन ऑफ कस्टडी के ऊपर हम कैसे रखेंगे और कंटामिनेशन नहीं हुआ है इसको कोर्ट में हम कैसे प्रूव कर सकते हैं सर?
ये जो हैशेस है ना, दे आर बेस्ड ऑन द कंटेंट, बिट बाय बिट कंटेंट ऑफ द फाइल। तो यदि हैश चेंज नहीं हुआ तो कंटामिनेट नहीं हुआ। चेन ऑफ कस्टडी इज स्लाइटली मोर देन हैशेस। चेन ऑफ कस्टडी मींस कि भाई आपने जब सीज किया तो किसने सीज किया, उसके बाद फिर अगला किसको दिया, किसके पास कब तक रहा, क्यों रहा, वगैरह वगैरह। सो फॉर दैट डॉक्यूमेंटेशन इज एसेंशियल। If you are going to a court and they ask for chain of custody, you should have the documentation to show that this file was written onto CD from where it was, the hash value was calculated, that is entered into your chain of custody document. फिर उसके बाद आप next आदमी को दिया, फिर अगले को, फिर अगले को, फिर अगले को, and so on and so forth. वो chain of custody आपका maintain होगा. आपका साउंड म्यूट हो गया है.
तो जो हमारे एल्गोरिदम है तो कौन सा एल्गोरिदम स्ट्रॉन्गर और कौन सा बेस्ट है सर अकॉर्डिंग टू योर प्रैक्टिसेस?
देखिए क्या है कि पहले MD5 स्टैंडर्ड होता था, तो MD5 के बाद MD5 का कोलिजन आ गया, उसके बाद SHA-1 स्टैंडर्ड होता था, वो SHA-1 के साथ भी कोलिजन आ गया. तो अब क्या करते हैं हम लोग, मतलब MD5 प्लस SHA-1 दोनों ले लेते हैं. तो अब क्या है कि there is the probability of getting a file with both the same MD5 and SHA-1 is not possible.
Okay.
Under the current scenario. तो दोनों लेने से अपना सही हो जाता है. But आप और भी ले सकते हो. You can take multiple hashes also. That is up to you. SHA-256, the SHA-512, 1024, whatever.
Thank you very much.
You're welcome.
Thank you.
Mr. Abhishek Adhikari.
First question is, like you already shown this the background, right? Like in case of Stuart, his background was blurred. So is there any mechanism from your side, like some software or hardware that can remove, or can it get back the original background, if we can have that? What was exactly the background? Can we have this? Because if some crime has been occurred with this camouflage and all, how can you detect that? What is exactly the background? And in case of the second question to Stuart, I'm not sure whether he's here or not. The size of the block in case of a hash. So that also depends. I mean, exactly what the data that you have already stored on your machine, it might be different for different machines and all. So what should be the size of a block for each of these hash algorithms that you are using here?
All right, so let me answer your first question first. Background. Even though the background is blurred, if we use child scene, it will look at characteristics because it is actually looking at pixels. It does not know what is there. So if the blurring technique used is the same for the same background, we will be able to do some sort of matching. We may not be able to see the background, but we'll be able to match different pictures with different people in them, but the same background. So if there's somebody sitting over here in this office and has blurred my background, the pixels that will be there in my background will be similar to when somebody else also sits in the same office, but the background will remain the same. So that is number one. Number two was that block level hashing. You're talking about the block size can change from device to device. Is that correct?
Yeah.
Okay. Now the key thing is that they are talking about block level hashing. Now normally what is a block? Block is like a cluster, it is a cluster. So it is a group of sectors. Each sector is 512 bytes. So now a sector is decided by the way your operating system is set up. Suppose I'm using say NTFS and I say that I want to set one block to say 4 sectors per cluster. So then I have a 2048 size of block, right? Now this gentleman is saying block level hashing, but this is their secret sauce. So I'm not sure what they're doing, but let me explain the way I have understood it. In my understanding, their block level can start at one sector. So let us take, for example, a sector. We have one large child pornographic file, which takes up something like say 20 sectors, just for the sake of discussion. Now they're hashing every block in that. So they have 20 different hashes for that file. If they find any sector, it could be overwritten, it could be deleted, but that sector may be the second sector. The first sector may be overwritten, because with a smaller file, for example. But the second sector may remain, the third sector may remain, which may have been part of that earlier block of which was part of another file. Now, if the second and third sector remain and they are found, that means that this will turn red. That look, child pornographic content existed on this system. So that is my thought process on how they are doing it. Stuart, if you are here, please jump in.
Yeah, if the file is stored somewhere, and if you have a shift of that, like if you have some kind of pre-processing things, then the file will be shifted a bit.
It doesn't matter. As long as the file starts at the beginning of a sector. If it starts at the beginning of the sector, the block level hashing will work, whereas the normal hashing will not. The normal processes will never work. But a block or rather sector level hashing will definitely work. It's a very brilliant idea, I think, in my opinion. The logic that they're using is extremely solid, because if we take this situation that there is a byte shift, right? Or there is a situation where sequentially you have moved rather than starting at the beginning of the partition or the beginning of where the file should start, it is starting from the second sector, third sector, fifth sector, or whatever, because something else has been inserted rather than actually overwriting and things like that. So then in normal detection, it will never show up because it is not as per the file system. But the key thing is that it may not be as per the file system, but it exists on the hard drive in that particular sector. So logically, if that sector is hashed and it has that, and if it exists anywhere, even though it is shifted, it is good for us. We will be able to find it. Useful. I think they've thought of a good idea.
Okay. Yeah, that's good. Thank you.
Thank you. Okay. I think once again we have exceeded our time, and but hopefully we have hoped managed to answer most of your questions. Okay, the question here is from Mr. Saste, who has authority to issue 65. If you are saying 65, do you mean 65B certificate? Yes, I see that. Whoever is the custodian of the records or whoever is providing the evidence has the authority to issue this, but this is something that you should take advice from a lawyer. Okay, we are forensic technology guys, so it is not correct for us to advise you on this. Ask a lawyer who has the authority to issue 65B and they will tell you. Thank you, everybody. Thank you very much. Okay, namaskar. Have a good weekend. Bye-bye.
Thank you, everyone.